Hey, it's Mr. Allred again. Still working on these first order linear differential equations. We've done 2 examples. We've written some rules. We're going to keep going here. Let's see here. We're going to add an extra element here. But let's start over here with another example, which will be x plus 1 times dy dx, or y prime, minus 2 x squared plus x times y equals something not too beautiful, e to the x squared all over x plus 1. But I say we're going to add something a little bit more interesting to this one. We've got an initial condition. We're also told in this problem that if we were to plug 0 into whatever the y solution is, we would get 5. So this is an initial value problem. And basically what this means is after we finish all the steps that we're used to doing, we can use this 0, y of 0 equals 5 to figure out what c is. So up to this point, c has been open, so that's a family set of solutions. But if we make it go through a certain point, then we get a very specific solution. But let's get into the process here. First of all, there's a problem. It's kind of in the template, but this guy shouldn't be here. This x plus 1 should not be times this dy dx if we want to use the first order method. So let's go ahead and divide it out. So we'll divide every term by x plus 1. So that cancels out of the dy dx term. Let's go ahead and while we're messing with the second term, let's notice we can pull an x out of the x squared plus x, and that'll give us x times x plus 1. And I say that because when we look at that, we can see it's going to cancel. Let's go ahead and mark that out. X plus 1 over x plus 1. Okay, but let's don't do it too early because we've still got some stuff to do on the other side. We're going to divide the right hand side by x plus 1. There's already an x plus 1 in the denominator, so we will just have it squared now. So now it is in the correct form. Okay. This is the correct form. There's a 1 in front of the dy dx right now. And if we look at what's in front of the y now, it's negative 2x. So it's going to be our p of x. Okay. That negative is kind of important. It's a big deal. So let's go ahead and find our integrating factor, which is e raised to p of x, which is negative 2x dx, the integral. So this is not too hard. E, if we integrate this thing, we will have negative x squared. Let me think about this for a second. 2, yes. So this is our integrating factor. So remember, we're going to multiply through by that. But how this is different from the other ones, usually we got e raised to a natural log of something and we canceled out the e. This time the e is still going to be there. So let's go ahead and multiply through by it. So we've got our integrating factor e to the negative x squared times dy dx. I guess we don't want to use plus, do we? Minus 2x, and then we'll put on our integrating factor e to the negative x squared y. And that'll be equal to, and we'll put in our integrating factor on the right hand side. We got to make sure we put it everywhere. E to negative x squared, and that's times what was already on our right hand side, which was e to the x squared over x plus 1 squared. So I don't know if we want to focus on one side or the other just yet, but let's kind of get up here and notice that I guess it would be good to just go ahead and clean things up. On the right hand side, we've got e to the negative x squared, which really means it's in the denominator, and then we got times e to the x squared, which means it's in the numerator. So those actually cancel out. So on the right hand side, we're going to have the integral of 1 over x plus 1 squared dx. Let's clean that up a little bit. And on the right hand side, on the left hand side, we haven't changed anything. We've got exactly what we see up there. E to the negative x squared dy dx minus 2x e to the negative x squared y. Now we put a lot of emphasis on this left hand side being the reverse power rule. So let's see if that works out. So of course y and y prime or dy dx is v and v prime. But let's look at the other part. E to the negative x squared is supposed to be our u. So the question is the other thing over there the u prime or the du? Well, let's look at it. Let's look at our u. E to the negative x squared. If we take the derivative of that, we've got the chain rule, which e to anything is itself, e to the negative x squared, but we also have to take the derivative of that u part, not u part, the g part if we're talking about the chain rule. So derivative of negative x squared is negative 2x. So yeah, it fits u prime. So the left hand side here is just u times v when we integrate it. So we get u, which is e to the negative x squared times y. Now on the right hand side, we see something we kind of may or may not be familiar with. It looks to me like it is a u substitution. So when you integrate, anything could happen. You could have partial fractions, you could have integration by parts, you could have a trig substitution. Let's see here. So if we're doing u substitution, u would be x plus 1, du would be dx. So we'd write this as basically u to the negative 2 du, which would be u negative 1 times negative 1, which if we plug our u back in, we would have negative x plus 1 to the negative 1, and then don't forget the plus c. So this is not the worst answer in the world, but remember this one was a little bit different because we got a little bit of extra information. Up here has been lost, but we had y of 0 equals 1, and in terms of our variables, that means that x equals 0 and y equals 5. So let's come down to our solution at the moment. And what we're writing in here, or substituting in, is x equals 0, y equals 1. Let me go back and check. Ooh, excuse me, y equals 5. That would make a difference in our solution. So we're going to plug those in and we can actually find c. Now, we could get c by itself before we do this. We could get y by itself before we do this. But let's just plug the numbers in and see what happens. So let's plug in. Well, let's plug in. E to the negative 0 squared times 5. That's exciting, right? Equals negative, our x is 0, plus 1 to the negative 1 plus c. So we plugged in our x and our y. Well, all this stuff over here it doesn't go away. Keep in mind that anything to the 0 power is 1. So on the left-hand side, we get 5. We've got a negative 1 to the negative 1. So this is 1 to the negative 1, so basically puts the 1 on the bottom, but 1 over 1 is 1, and it's negative, so negative 1 plus c. So this leads us to c being 6. If we add 1 to both sides. So in these conditions, we could go back and we could complete our differential equation with that initial condition, where we would have e to negative x squared times y equals negative x plus 1 to negative 1 plus 6. So that solves the original equation we had up top that we were given, and it goes through the point that they gave us over here. If you're into cleaning them up, we could divide by the e to the negative x squared, but that's already on the bottom, so technically we could multiply by e to the x squared. So if you wanted to clean this up one more step, you could have y equals, so if it's on the bottom now, you would put it on the top to move it. And this x plus 1 had a negative 1 on it, so we go to the bottom. And don't forget that this thing that we just multiplied by, e to the x squared, would hit that c as well. So just multiple ways to write your solution. Okay, now it'd be time for some work on your own.